question as we go, if you've been following, because I'm basing this one on a certain lecture we had earlier. So your question is not going to take us back to go and talk about that. So if you've always been in class, then you can ask a question and we can look at it based on your previous knowledge. You need that previous knowledge on topology to understand this one. And so most questions that are asked link topology with network analysis. It's natural. Are you okay? So a question that when you see a set of questions, maybe question 4, what is network, blah, 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 you see topology hiding in there somewhere. All right, great. So if you have topological errors in your data, then naturally you are going to get the wrong routes. If you have you do network analysis. Okay, that's one question that I always ask. I don't enjoy students not passing, but sometimes the question is just tricky. Okay, let me just go back up here. So if you have a topological error like this, you correct by trimming. So this is something that's done in AutoCAD. Okay, we do this in AutoCAD all the time. You trim. If you know how to do it, select it, trim, click this part, it cuts it off. Okay, and that is not what we are even talking about. See, so if you know AutoCAD, there's a limitation. When you trim this, it will look like, you know, let me actually clean it up, just so that I can do this properly. So all this bit is gone, but it's still not correct. This is what we call, I don't know what you want to call this one, cul-de-sac or something like that. Like you have a road that goes, it doesn't connect, it gets close to a main road, but it does, you can't enter into the main road. That's a typical example. You can have a situation like this. It's not a junction. Okay, so the data that you have represents, you are saying something to us that is what happens on the ground. It may not be at all. So that's networks for you. Let's go back to my PDF. Like I said, we have to understand this. Now, most network analysis require that we have real-time data. Let's say an Uber driver wants to pick you up. Okay, and when you actually made the request, immediately made the request and it was accepted, then he set off right there. That's not the time to say, I want to use 1986 data, please. That's not the time, because 1986, that building wasn't there where you are living. So you need real-time data. You need to know exactly where he is at a point to know whether he's actually coming to pick you up or he's not. So that's a system requirement. I've never asked questions on things like this before. You never know when I'm going to ask a question on that. Okay, but it will make sense. Now the system has to be compact. I mean, compact is compact. Should have address conversion functions, like getting to know where exactly you are on the network. Okay, so here you're talking about road network typically. It has to be up to date, it has to be accurate, you can make mistakes. I asked a question about Google Map leading people to have road clashes. I don't know, road crash. This is not a clash, it's a crash. Like you driving into the wrong place because Google is doing a network analysis for you and it's telling you that that's the route you have to take, and then you end up in the wrong place. In fact, there are certain places you don't want to end up. Are you okay? Could be too dangerous for you. Your own personal security and safety. Are you okay? All right, down here you see the data requirements. Are you okay? In fact, you will need to realize, everybody here, I think we talked about attributes before. What are the attributes of, the dimension and objects? The last time we were talking about layers for an agricultural business or a farm or something like that. And then in the class, Hassan, they're all making contributions and people are giving the, different interesting answers. They were all correct. But attributes is what it keeps occurring to me that we haven't, touched more on it. What are attributes? So the attributes of a person, it could be that he's too tall, he's too short. Same way in a network, we can say that for a particular link, like I said, we can talk about speed restrictions being an attribute of a particular road segment. We can talk about the road condition. Like I said, if it's depending on the class for road, you can literally tell that it's a good one or a bad one. Are you okay? Classification, we talked about that. Turning restrictions, can I turn? And would we say turning restrictions are actually attributes of the junction or the road itself? I'm thinking you can turn at certain points on the road. Yeah, so it's a particular point where you can't do the turning. It may not be a junction, so that's an interesting one. Okay, so with height restrictions, okay, so if I'm traveling on a road and I need a shortest path along it, then I'm going to always think about the kind of vehicle that I'm driving, because there are some roads where you cannot drive on because of the height restriction or the width restriction. Junctions, roundabouts, etc. Reference marks. Are you okay? All that go into it. So a network is just an example of an entity, a type of representation. A network can be defined as a set of linear features through which resources flow. Is that okay? Resources flow through that network. All right. Nodes. So another name for a node is the endpoint of a line. It's a node. The endpoint of a line is a node. It has to be an endpoint. All right. And the nodes are used as origins, destinations, and links. So we talk about links or lines, like they could be arcs. So don't forget the reason why we use the word arc, because the vertices define the shape of it. So you can have a line that is not straight. It's still a line, isn't it? But then the word arc would be more appropriate in GIS context. Okay. So the links, are you okay? Traverse. So traverse. So the word there's an E at the end of it that is missing. Is that okay? You traverse from one node to the other. So in the example of the rail network, we are able to traverse from one node to the other. And the nodes were those round things, which are actually junctions. Is okay? Which means that at that point, we can have a change. We can literally move from one to the other. If you can have that change, then you are having what we are having at Pokwasi, that kind of interchange where people are moving at the same place but at different hierarchies, at different levels. Okay, all right. Nodes can have properties, but in network analysis, we are usually more concerned with the characteristics of the link. So you will see why we're not talking much about the attributes of the node, the junction itself, because the junction can have a few attributes associated with it. They may not be so interesting. That's all I can say. Is that okay? All right. So some of the attributes of the link, we already talked about speed restrictions and all that, but obviously basic length, the direction in which we can move. Are you okay? Connectivity. Are you okay? So lines must connect at least 2 points. I think we talked about that. And we can also look at patterns. Is all right. Okay, so now let's just consider a few of these. All right, so for any particular network, we can have it to be unoriented, unoriented with loops, and oriented with loops. Is that okay? So if it's oriented, of course, it means there's a direction, sense of direction of the network. Well, what it means is this, that you can actually move in one way and you may not be able to move the other way. I mean, as you go to Accra, you realize that we have that one-way system. That is the whole idea of oriented networks. Some, not all networks are actually looped. Some networks just go, and they are connecting all right, but you can't come back somehow to the same point. Is that okay? So yeah, it's worth touching on that. Very important. So here on oriented, we don't even, there's no direction. Are you okay? We can't tell whether once you're on a particular link, where are you going to? We don't know. All right. But oriented means that we can have direction associated with it. Once you get to this point and you go on this link, once you decide to go this way, you're only going to be forced to go that way. Are you okay? All right. Once you decide to branch off on this, you are going that way. Okay. And you can't be here and be going this way. Are you okay? You can't be on this link and you always be going that way. All right. Okay. So you can model existing systems, or you can design a network and then implement it. Put that in your mind. Okay. So that is it. You can have the loops. So these are looped. This is looped on the right hand side. On the left hand side, these are not looped. These are unoriented. These are looped. Okay. These are oriented. This is looped and oriented. Is that okay? So it's important to know that, yeah. So rivers flow in one direction only. So you can see that if you have a stream network, then that's that type of network is actually oriented, isn't it? Roads, what does it depend on? It could be oriented or not oriented. Is that okay? So it's oriented.
Yeah.
Roads, are roads oriented or not oriented? Someone's mic is on.
Yeah. Some are oriented and some are not oriented.
Okay. All right. That's correct. So yeah, what's the explanation for that? Because one-way streets,
yes,
are more oriented.
one-way.
Yes.
Yes.
Now, if you know how rail work, it depends on this. They have, I don't know how they do it. For a rail, what I hear is that the engine doesn't have any facing per se. It's not like a car. For rail, train. It's not like a car where you know that nobody drives his car by facing the back. I don't know. Isaiah, I don't know if you've tried that, but the car, you go to the back seat and you are driving. No, it doesn't work. For rail, it's funny. It seems it can move in any direction. So you need to understand the particular system. In GIS, any question that you are asked, it's explained to you. We are not going to hide it from you and expect that you know everything about how trains work. So any questions on trains, we'll explain it to you. Then it's up to you to decide. At the heart of a network analysis is a search procedure. So we need to find the shortest routes. Are you okay? We need to select the links. Are you okay? That take you as far away from the start node as possible. That's an example of a search in network analysis, network operations. Is that okay? You always want to find out the particular routes by selecting the links. Is that okay? So that blue line that you get in Google Map, that shows you from here to